Hello everyone, welcome back to Cambridge Guru channel. Today I'm going to start with a new unit, further integration. We have already covered 7 units of our 9709 pure mathematics A level paper number 32 course. So this is our 8th unit, which is further integration. So without wasting any time, let us start with the first topic, which is integration by substitution. It says that let us take an example that the graph of under root of x minus 1 is shown in the adjoining figure. The shaded area is given by if you integrate the given curve from the limits between the limits 1 and 5, right? So I think you know the definition of definite integral. It gives you the area under the curve between the given limits. So if you integrate root of x minus 1 between 1 to 5, this will give you the area under the given curve, which is the shaded region here. The shaded region means it is shaded with this green color, right? So now the question is how we can integrate this given integral, because if you take x minus 1 root or x minus 1 raised to power half dx, so we cannot integrate this like you do in, let us say, if you integrate this as x minus 1 raised to power half plus 1, which is 3 by 2 upon 3 by 2 upon 2 by 3. Okay, so directly we cannot do this. There is a different method and then you can do the question directly, but straight away we cannot integrate this, right? So what we can do is we can substitute some variables with or in place of another variable, or we can substitute one variable to another variable. Okay, so now what is the method of this substitution? Let us see. But before that, let me give you one property that how we can use this method of substitution, or why this substitution holds true in case of definite integral. So basically, definite integral follows this property that if you are integrating any function fx, since the function is fx and you are integrating it with respect to x, so you will introduce the variable dx, and between the limits, let us say a to b, right? This integral will be equal to another integral ft with dt. Means if you substitute or replace the variable x with another variable t, provided the limits will remain same. Limits will be changed, of course, right? But basically, geometrically, the meaning of this is that area under the curve, if you are integrating that curve between a and b, that will be equal if you integrate the curve with another variable ft, but the limit should remain same, right? So it doesn't matter that you replace the variable x with any other variable, provided that the area should remain same or the limit should remain same. Okay, so this is a very important property for definite integral. So that's why we can substitute or integrate using the method of substitution. Okay, so now how we can substitute something or how we can integrate this given integral. Let us see that if I take, let x minus 1 is equal to some another variable dt. So our given integral will reduce to integral. Let us put these limits later on, but let us see how the function is going to change. So since x minus 1 is t, so it is just t raised to power half. Okay, now if you write this as dx, you will see here that since the function is in terms of t, but here it is dx. So dx is simply saying that you are integrating with respect to x, but there is no x here, right? Since you have replaced the variable x with t, so you have to integrate with the variable t. So here you need to find out the value of dt basically, right? So since x minus 1 is equal to t, so from here only we will find out the value of dt or dx in terms of dt. Just like we have replaced x minus 1 with t, or x is t plus 1, similarly we will write that the value of dx in terms of dt, and from this very same equation. So how we can obtain this? The method is that you differentiate this equation x minus 1 is equal to t, right, with respect to any other variable, right? So I'm directly replacing, or let us say you are differentiating this given function with respect to t, right? So if you are differentiating dx, so you will get dx over dt, and since 1 is constant, its derivative is 0, and t derivative with respect to t is 1. That means here now you have the value of dx as dt. Okay, so t raised to power half dx, so dx value is dt. You can directly say that, okay, since this is dx and t is going to be dt. Okay, the more you do some question on substitution, you can directly find out the value of dx by differentiating this with any other variable and then cancel along that variable. Okay, so integral of t raised to power half reduced to integral of t raised to power half dx value is simply dt. Okay, now there are two things or two method. Either you replace the limit in terms of t, which is the correct way of integrating, right? Since you are replacing x with another variable t, so limit has to be changed. Second is that you first integrate this once you obtain the integral, right? And then put the variable back from t to x, and then there is no need to replace the limits. But I would prefer that you change the limit. Okay, forget about this integral once you have substituted, right? So now integral has reduced to t raised to power half dt, so accordingly change the limit. So how we can change the limit is that since the lower limit value of x was 1, so you put x equal to 1 here, you will get t is equal to 0, right? Since x minus 1 is equal to t, here you will first put lower limit for x, which is 1, so 1 minus 1 is 0, so I will get the lower value of t as 0. Okay, similarly the upper limit for x was 5, so here upper limit of t will be 5 minus 1, which is 4. So basically now you have to integrate 3 raised to power half dt between the limits 0 and 4, right? Now how we can integrate this is very simple, that t raised to power half means if you integrate this, you will get half plus 1 is 3 by 2, and upon 3 by 2 means 2 by 3. Okay, now put the limits from 0 to 4. So this is 2 over 3. Upper limit is t raised to power, 4 raised to power 3 by 2 minus 0 raised to power 3 by 2. So 4 raised to power 3 by 2 means you first take out the square root of this, right? Means that I always say that if you are having a rational or a fractional index, so first try to remove this upon denominator index. Okay, so it is 1 upon 2, so write this 4 in terms of a power of 2, right? So that you can cancel this 2 with this denominator 2. So it is 2 square, that square get cancelled with this, so basically it is 2 cube, which is 8. So 2 by 3, 4 raised to power 3 by 2 is basically 8, and this is 0, right? So it is 16 over 3, right? This is your final answer, right? Let us take another example, that evaluate this by making a suitable substitution, right? You will get some question where it won't mention you that you have to make a suitable substitution. You have to analyze the integrand and then think yourself that which substitution will be suitable. So here again, x plus 1 raised to power 3, you cannot directly integrate this. One method is that you can apply the property of a plus b whole cube, which is a cube plus b cube plus 3a square b plus 3ab squared, and then integrate these four terms separately. But it is easier to use the substitution method. So solution here is that let again you substitute this x plus 1 is equal to t, and here only differentiate this, you will obtain the value of dx as dt, because the differential of 1 is 0 and t differential is dt, right? So now your integrand is integral of x plus 1 raised to power 3 means t cube, and dx value is dt, and replace the limits. Since the lower limit was 1, so lower limit for t is 2, and this is 4. Okay, so basically what you have done here is if I explain this in this figure, that once you have replaced this the limits from 1 to 5, so basically what you have done is now the limits are 0 to 4, so the graph is now shifts to 1 unit towards left. Okay, so now the area is this, right? So consider this as a piece of cake. You are just shifting this piece of cake in horizontal direction. If I say what will be the area of this piece of cake if you shift 1 unit towards left or 1 unit towards right, the area will remain same. Okay, so changing the variable from x to t and thereby changing the limits from 1 to 5 to 0 to 4, it doesn't matter. Okay, provided your substitution is correct, right? That's why we say that substitution in finding out the definite integral is a very you can say handy process, right? Easier process. Okay, so here this is that limits now change from 1 to 3 to 2 to 4. Now you can easily integrate this. This is t raised to power 4 over 4. Put the limits from 2 to 4. So 4 raised to power 4 is basically how much? I think it is 256. 4 cube is 64, and yes, 256 over 4 minus 2 raised to power 4 is 16 over 4. Okay, so 256 by 4 is 64 minus 4 is 60. This is your final answer. Fine. Illustration number 2. Evaluate this by making a suitable substitution. Now here you can see that this is x square minus 4 raised to power half, right? Whenever there is a question given to, and this statement that I'm going to say that I will repeat multiple times in this unit, because there are 3 methods of integration that we will use. So whenever there is a question that comes in the exam, you will see the first process, which is your substitution. Now how we can apply a substitution is, you just look that what are the terms that are creating some problem in the question, right? Since there is an x and there is x square minus 4, had it been directly x minus 4 or x square minus 4 raised to power half, we can deal this with some substitution. But there is x also, and I cannot multiply this x into the under root because that will make the things more complex, right? So this 2x is creating problem and this needs to get removed. Now how we can remove this? One way is that you can substitute this 2x as t, then you will get value of 2 dx is equal to dt, right? So 2x is t, so now your integral reduces to t over 2, right? And then x square minus 4, you will replace x square value as t square by 8 minus 4 raised to power half. The purpose is not solved, I think, right? So the moment you try to substitute some variable with another variable, and if the things are getting more complex, you will realize that that substitution is not correct, right? Then try for another substitution or go for second number, which is x square, not number, the second expression, which is x square minus 4, right? Because this is under the root. This is again a very complex thing, because since here we are substituting x minus 1 as another variable because it was under the square root. Here it was x plus 1 cube, here it is under the index 3. Again, this is x square minus 4 raised to power half. So let us try to substitute this, whether things will get easier or no, right? So now let us quickly substitute x square minus 4 is equal to t, right? Obtain the value of dx and dt, means substitute or differentiate this. You will get 2x, means applying the chain rule, differentiating this with respect to x and then dt, right? So this is 2x dx is equal to dt, right? 2x dx is equal to dt. Simply what we are doing is we are differentiating this equation with respect to t. Okay, so if you are differentiating this with respect to t, for x square you will first differentiate this with respect to x, which is 2x, and then differentiating x with respect to t, it is dx over dt, right? And lastly, we are transferring this denominator dt to RHS. So we can simply write in single line that this differential is 2x dx is equal to dt, right? Now you can realize here that this 2x and this dx, these are in multiplication. So 2x dx are simply reduced to just dt. First thing is solved, that this 2x is gone. Second is, since I have substituted this x square minus 4 is equal to t, so now this whatever were the terms inside the square root, that again has been reduced to just root of t. So now things are getting more simpler, and I think this substitution will work, right? So 2x into dx is reduced to dt. So now my integral has been reduced to that integral 2x dx is dt and x square minus 4 is t. So basically it is t raised to power half, and 2x into dx is just dt. So now integral is reduced to this simpler integral by substituting x square minus 4 equal to t, right? So how I approach to this is, since I know that this x square minus 4, if I substitute this as another variable t, I will get the derivative of this 2x. Derivative of x square is 2x, right? And that 2x can be removed when I replace this 2x dx with this dt, right? So thinking about this term x square minus 4, and then thinking about the value of dx, right? When we differentiate this x square minus 4 in terms of t, I will get 2x dx, and this 2x dx will be removed, right? So you have to think in this line of order, right? Which substitution I should put, and then second step is finding out the value of dx in terms of dt, right? And then combine some, there will, or analyze that whether there will be some combination so that the extra terms in the integral, whether they can be removed or not, right? So now change the limit, that since initial limit or lower limit was 3, so this is 3 square, which is 9 minus 4 is 5, so lower limit is 5, and upper limit is 16 minus 4, it is 12, right? So now it is a piece of cake. So t raised to power half is 3 over 2 into 2 by 3, right? Raised to power, limits are from 12 to 5. Now you can use your calculator also, because we do not have any value for this 12 raised to power 3 over 2 minus 12 raised to power, not 12, 5, lower limit is 5, 5 raised to power 3 over 2. Okay, fine. Let us do another question, that by making a suitable substitution, find this integral. Again, you can see that this x is creating a problem, right? And this is x minus 2 under root. Now, let us see how you can remove this x, or how you can make this integral more simpler. If you do x minus 2 as t, you will get dx is equal to dt. And if x minus 2 is t, value of x, that won't get vanished, because dx is just dt. So you have just replaced this dx with dt. There are no x attached to this. And x minus 2 is t, so x will be t plus 2. X will be t plus 2, right? So this x is not removed. So now integral is t plus 2, and this is x minus 2 root is t raised to power half. Now you will see that things are not getting more simpler, but in a way they are. In a way they are. Why? Because now you can multiply this t raised to power half with t plus 2. Why I am saying this, we can multiply? Because we can multiply this initial x with under root of x minus 2 also. If you are multiplying this x with x minus 2 root, what you are doing is you are multiplying this, your answer will be that it will be x raised to power cube, because you will square this, minus 2x square, and then there is a square root. Okay. If you substitute x cube minus 2x square, again you will get 3x square minus 4x dt. That won't help you, right? So we cannot multiply the x in the original question with the under root of x minus 2. So what we can do is, let us first replace or substitute x minus 2 with another variable t. Now I can multiply this t raised to power half with t plus 2. And how the things will get simpler, let us see that this is t raised to power 1 into t raised to power 1 by 2 plus twice of t raised to power 1 by 2. I can separately integrate this. And of course, this is dx is equal to dt, right? This is dt, this is dt. So it is equal to t raised to power 1 into t raised to power 1 by 2 is basically t raised to power 3 over 2 dt, and plus this is twice t raised to power half dt. So now you can simply integrate this. T raised to power 3 by 2 is t raised to power 5 by 2 and into 2 by 5, plus this is twice of t raised to power 2 by, sorry, it is 1 by 2 plus 1 is 3 by 2 upon 3 by 2, which is 4 upon 3 plus c. Okay, this is your integral I. This was a indefinite integral. In indefinite integral also we can use substitution method. Okay, so I hope now the substitution is clear to you. We'll come with some more question on substitution. Please write in comment section that how do you like this video. Please like this video and share this video to your friends, right? And just subscribe my channel and click on the bell icon, and please mention any issue or any other problem that you face in any topic as far as A-level mathematics is concerned. Okay, see you soon. Take care. Bye bye.